Hi and welcome back. Today I will continue with this infrared sensor. We have seen on the previous episode that this system gives two voltages X and Y, which permits to have a spot. The location of the spot on the screen of this oscilloscope corresponds to the location of the infrared source. There is another feature on that system which is quite complicated. One part of this system is this schematic here. We have seen that on the anode of the PMT there is a square wave. This square wave is filtered using this bandpass filter at 100 Hz. At the output there is a sine signal. The phase shift of this sine signal regarding the reference signal depends on the location of the infrared source. This signal is fed to this amplifier, and at the output here there is a square wave which is fed to the phase detectors. We can see that there is another input here to this amplifier. This input is connected to this differential amplifier. So this circuit is actually an analog multiplier. One input is a square wave at 4 kHz. We have seen on the first episode. At the output here there is the same square wave, but with an amplitude which depends on the bias current flowing here, and this bias current depends on this voltage. And we can see that this thing is not linear. What is the effect of a 4 kHz signal here? To understand the goal of that thing, it is better to see at the limits. When there is no signal here, this circuit works normally. At the output there is a 100 Hz square signal which is fed to the phase detector, and at the output of the phase detectors we have maximum voltages. But if we consider that we have a large 4 kHz amplitude, at the output there will be mainly a square wave at 4 kHz, and in that case, at the output of the phase detector, we will have actually a null voltage. This circuit permits to reduce X and Y voltages in order to change the position of the spot regarding the center. This signal is connected to another circuit which is on another board. It is this circuit here, so we can see that there is a PNP transistor here. This VBE voltage compensates the VBE voltage of Q2 here. We can see that there is an inverting amplifier here, there is an offset adjustment, and the input of this amplifier is connected to this relay. This voltage can be connected either to one pin of the connector, otherwise it is connected to another circuit. I have activated for the moment this relay, so therefore it is possible to apply a voltage. This voltage should be negative, because at the output we should have a positive voltage for the multiplier. On that setup I have connected this oscilloscope to the output of the phase detector. This one actually. I have connected this potentiometer to the input here. The potentiometer is supplied with a voltage of minus 12 volts, so therefore it is possible to change this voltage from 0 to minus 12 volts here. I am going to activate the power supply of the shutter. Okay, so we can see the position of the bulb here. It corresponds to the location of this spot here. Currently the input voltage is null, so let's decrease this voltage from 0 to minus 12. And you can see the effect on the spot and the effect at the output of the phase detector. Okay, so you can see the spot here, and you can see the effect of the 4 kHz signal. So here we can see that at the output of the phase detectors we have signals close to 0. The 4 kHz signal permits to switch from a positive voltage to a negative voltage. So after filtering, the mean value of this signal is null. So therefore it is possible to adjust the output voltages of the phase detectors from 0 to the maximum value. This permits to have also an indication of the distance from the aircraft to the target. So there is another board, which is the board SK2. I have done a SPICE simulation of this circuit, and we have two identical circuits, and this is a nonlinear function, which is actually a square function. For an input from -5 to +5 approximately, so we have at the output the input voltage squared, multiplied by a given factor. So this is actually the output current here. These two inputs are connected to the x and y coordinates. The outputs of the low-pass filters, which are located after the phase detectors, is actually the signals x and y on the oscilloscope here. So this is interesting. We can see that we have the sum of these two currents. We have the sum of the cosine squared plus the sine squared, which is 1. As the output, we have an image of the distance, the distance from the center to the spot here, squared. This voltage is negative, the current flows in that direction here, so therefore the output is negative. The output here is fed to this circuit, so we can see first that the output is positive, because we have a negative voltage here, and we can see that there is an integrator, and this output is fed to the gain control, to control the position of the spot from the center. That's all for this infrared sensor. Thank you for watching, and see you next time for another video. Bye bye.